Captain Hoff here with Founder Space. Today I want to talk about quantum computing. What is quantum computing? What isn't quantum computing? First of all, let me start by saying quantum computing is mind-bogglingly hard. It's not the simple thing you may have heard before. People explain quantum computing by saying normal computers have a transistor that has two states, a 1 and a 0, basically an on and an off position. But quantum computing has many states, so it can be in many states at once, and therefore it's much faster. Well, this isn't right. Quantum computing is fundamentally different from any other type of computing. It's not just about having more states. Because in quantum computing, when you have many, many more states, if you are just looking at them, they will all sync up due to quantum entanglement. So even if you have thousands or hundreds of thousands of different possible states or millions, when one changes, all of the others will change in accordance. What's interesting about quantum computing is not the states, but the path you go down. It's quantum computing, if you want to conceptualize it, and it's really hard because it's happening in a quantum world, it's like waves or ripples on a pond. Now, what are these ripples doing and how do they interact? Do waves coming on a pond from different directions, do they cancel each other out? Do they combine and become bigger waves? The interaction of all the different waves on the pond, all the different qubits and all the different quantum states is the computing power. It is this ability to simulate on a quantum level what's happening, where the power of quantum computers comes from. And ultimately, quantum computers will be good at doing certain things and not good at doing other things. Quantum computers won't be good at doing most of what our integrated circuit-based computers do, what like transistors do. They are not going to be good at booking travel reservations or good at browsing the web, or you won't have a quantum computer, in other words, on your phone anytime soon because it will be totally useless for you. What quantum computers will be exceptionally good at is modeling quantum states. So for advanced research into quantum chemistry and quantum physics and all these different things that we need to understand to actually know how our universe functions and potentially gain benefits from that, like creating new materials and understanding space travel and all of this, quantum computers will be incredibly valuable. They won't solve a lot of our practical problems that we're dealing with now on the web. It's not just a faster computer. It's a totally different type of computer. One thing, though, that you will see quantum computers used for is creating encryption, super advanced encryption. So the whole encryption game is about having encrypting data that can't be hacked by nefarious forces. With quantum computers, suddenly we will be able to start to we'll be able to model these encryptions and hack them. We'll also be able to use quantum computers to generate much more powerful and hopefully non-hackable encryption and security. That's an area that will affect the entire internet and almost every business on the planet. So that will be very important in a practical way. And then other ways we will see how quantum computers affect commerce, business, whether we use them, whether the average person uses them, or we just rely upon the encryption that they generate. So, quantum computers are going to be revolutionary in many ways. They aren't going to get here as fast as some people say. It takes time. IBM released a quantum computer, but the qubits aren't enough, and it isn't really a fully quantum computer to really do the type of work that the potential for quantum computers has. It's a baby step in the right direction. There are other companies that have been modeling different types of quantum computers. Some of them are taking kind of the dirty path, kind of hacking it out, and those probably won't pan out. It will probably be the cleaner path, which takes a much longer time to develop, that will see actually producing viable, consistent results that we can use both in scientific research and in encryption and in other areas. That is my short lecture on quantum computing.